Okay, so Theorem 4.7 and Theorem 4.8. Now, Theorem 4.7 says if a point lies on the bisector of an angle, the point is equidistant from the sides of the angle. So notice we have a drawing like this in the book. Lots of points, A, B, C. X, P, Z, Y. Okay, now we're given only that P lies on the bisector of the angle. Okay, so we know that that is equal to that. And we want to prove that this is the same as this. When it says then equidistant from the sides of the angle, the distance from a point to a line, remember, is defined to be the perpendicular. So the distance from the point to the line is defined to be the perpendicular. So we can have one uniform thing instead of just going all over the place. So if we go from P to A, that'd be the distance from P to A instead of from P to the line. We want to get generally the shortest distance, and that'll be the perpendicular. So we've got this bisecting the angle, so we have two equal angles. And if we look at the triangles we form, we have two angles equal, and they share this side. So we already know, angle, angle, side. So the two triangles are equal by angle, angle, side, and then by CP, CTC, XP equals PY. So let's write that up to make sure you got it and understand what's going on. So we have our given, let's see, BP bisects angle ABC. And that is our given. And then by definition of angle bisector, remember we know that angle 1 and angle 2, 1 and 2 are congruent. Definition angle bisector. And we know BP is congruent to itself. Identity. And then we've got, if we draw the perpendicular here and here, we know that they are give a right angle. So BX perpendicular PX and BY perpendicular PY. So basically, we've got a postulate that says through a point not on the line, there's exactly one perpendicular to that line. Okay, so through a point P, not on this line, there's a perpendicular to the line, one and only one perpendicular. So we've got those. And then we know 3 and 4 are right angles, so they're congruent. Okay, so all right angles are congruent. So 3 and 4 are congruent. 3 here, 4 here. And then by angle, angle, side, the two triangles are congruent. I'll go ahead and put that up here. Erase this. I can start on line 6. So triangle XBP is congruent to triangle YBP, and that's angle, angle, side, and therefore AP equals PY CP CTC. And we're done. Because we've shown that the point is equidistant from the sides of the angle. Theorem 4.8 says that if a point is equidistant from the sides of an angle, then the point lies on the bisector of the angle. So this time, okay, we've got a point somewhere. Okay, at this point, we're going to say is equidistant from A and C. So that's all we're given. We're given a point, so that AP equals PC. And we want to see if this is on the perpendicular bisector or not. So, as always, let's put down our given. AP congruent to PC given. And then, you know, as usual, we want to try to find some triangles to show that these are congruent. So we got to make some. We'll draw an auxiliary line right here. So draw in BP. So, you know, we can draw BP because 2 points determine one line. It's one of our postulates. So that's congruent to itself. Okay, so remember that since we're dealing with distance from a line, we know we got the perpendicular. So we know that that's a right angle and that's a right angle. Okay, so since that's a right angle and that's a right angle, we have two right triangles. So triangle APB, triangle CPB, our right triangles. Definition of right triangle. And then by the hypotenuse leg theorem, hypotenuse leg, the two triangles are congruent. So I'll erase this and start up here. And y'all keep going. So 5, we know triangle APB congruent to triangle CPB by the HL theorem, and therefore angle 1 congruent to angle 2 CPCTC, and therefore BP is a bisector of angle ABC by definition of bisector. Alright, cool. So those are the theorems in this section. Good. So make sure you study those, understand them, maybe memorize them. It's a good use of congruent triangles and good examples of proofs. So on to the next section.